Good morning.
Good morning, Angela. How are you doing?
I'm good. How are you doing?
Good. Especially today. I'm going to get to play golf today.
Oh, you are going to or were?
No, I am. No. I am.
Good.
For sure. No, I get plenty of time to play golf in the summer. So, okay, I have my notes as we finished up quads, quadrilaterals last time, and circles are next. The following disciplines that we have to cover are circles, solid geometry, coordinate geometry, and counting and probability.
Okay.
And then if we have time after that, we can, we've got another test and a half that we can do.
Good. Okay.
So hopefully we'll get.
And I definitely know I need help with the coordinate geometry. I've been trying to go over that a little bit, and I'm not very good at it.
Okay. All right. Most of the circles, I think we can probably get through this pretty quick. I think you're pretty good on circles, if I remember correctly.
Well, thank you.
So what's the circumference of a circle whose area is 100 pi?
It's going to be 20 pi.
Okay. Number 2, the area of the circle whose circumference is pi.
Two pi? No. Yes, 2 pi.
Okay, so R is equal to C over 2 pi. So
Okay.
the area is equal to pi R squared. This pi cancels with this. Well, let's see. This is now should be pi over 4.
Oh, that was way off.
Okay. The only two, obviously the two most important things you need to remember about circles are this and this. And then all of the questions generally come down to finding radius.
Okay.
Although they can certainly word them strangely sometimes. Let's see. So what is the area of a circle that is inscribed in a square of area 2? So we have, there's the square, and inscribed in means this. And the area of the square is equal to 2. What's the side of the square equal?
Well, the side of the square is going to be the square root of 2.
Okay.
So the diameter is the square root of 2.
Okay.
Which means the radius would be the square root of 2 divided by 2.
Okay.
So it would be pi r squared so pi over 4.
Okay, if I square this, I get 2 over 4. So it's pi 2 over 4 or pi over 2. 2 pi over 4 is the same as pi over 2.
Okay.
Okay. Let me erase this. In fact, you have these memorized. There's no point. I don't need to leave those up there. The area of a square, no, I'm sorry, a square of area 2 is inscribed in a circle. Again, what's the side of the square?
Square root of 2.
Okay.
So the diagonal, we'd make a
So the
diagonal
diagonal in the square,
and that would be 2. So then it'd be pi 1 squared.
Or just pi.
Right, pi.
Okay. And a 5 by 12 rectangle is inscribed in a circle. Apologize for my lack of drawing skills.
I don't have any either.
What is the radius of the circle? And that's the diameter. Might not be totally obvious why that diagonal is the diameter, but it is. In other words, whenever you inscribe squares or rectangles in circles, the diagonal is always the diameter.
Okay. And in this case, the diameter would be 13.
Okay.
So the radius of the circle would be 13 divided by 2.
Okay. Okay, now the question is, I guess they would allow 6.5 or 13/2. I'm sure they would. Okay. Boy, there's been an explosion of computer testing and math now. I've just run into a ton of it in the last 4 or 5 months. And it's terrible because you have to put in the answer precisely in the way they want it. Otherwise you get it wrong, and they don't, it's just awful. Much as
I know, I'm going to have to look up the one that you just said. I don't know if I can put 13/2 or not.
Yeah. Well, you'd be safe there with 6.5, but some of these tests where they're not multiple choice, in other words, the new thing in math testing for like college freshmen and stuff is these computerized tests where it's not multiple choice. You put in the answer, and they're very complex math problems. So it's so easy to not put the answer in exactly the way they want it. Even if you understand completely the problem, it's really difficult to get through the test. It's, I feel it's a bit of a misstep, maybe a first version of the software that eventually they'll correct, but it's brutal. It's really brutal.
Yeah, I'd say in the meantime, everybody suffers from it.
Well, and then they've designed it really poorly too. They ask you calculus questions, and they put in these 5 decimal numbers, and they make you work 90% of your time on arithmetic, not calculus.
Oh no.
It's just it's really a frustrating thing to have to deal with. And I'm a huge proponent of internet learning and education. It's just, I think they've taken a bit of a misstep with this new software that's showing up everywhere.
Yeah, and unfortunately that happens, and then they finally improve it, but it usually takes a while before they do.
Yeah, and everybody that's suffered through it, I don't feel like these students are learning calculus. It's just not a good enough thing. But anyway, that's another story. Let's look at number 6 here. The area of the shaded sector is 85% the area of the entire circle. What is the value of W?
Okay, and this one, I don't know, I think I would back solve. Well, I know it's 15%.
Okay, so if W is 15% of what?
360.
Right,
So it's going to be 54.
right. So I would really not think that this would be a back solving problem, because even if you back solve it, you have to know this.
Right.
So if you know this, you don't need to back solve it. And you might waste some steps unnecessarily testing some answers. But okay, the circumference of a circle is A pi. The area of that circle is B pi. If A is equal to B, what is the radius of the circle?
So let's see, A pi equals B pi?
No, because they're not saying the circumference is equal to the area.
Okay.
Just saying the constant A is equal to the same. In other words, the coefficient here is the same as the coefficient here. Probably when you see a circle problem, the very first thing you want entering into your head is that this is a radius problem. Even without looking at that, even if I was not looking at this problem at all, just the fact that we're looking at circles, it tends to be a radius problem. Not really so with 6, but most problems are radius problems, which means you want to set everything up using 2 pi r equals the circumference. So if the circumference is equal to A pi, let's let that equal 2 pi r. And if area is equal to B pi, we know area is pi r squared. So they're the same r. So if we can relate circumference to radius, and we can relate area to radius, then we should be able to relate the area to the circumference, and knowing that A equals B, we should be able to solve for the radius. So, what is the radius equal to in terms of the circumference?
In this case, A pi over 2 pi.
Okay. And for area, what is the radius equal to?
It would be the square root of B pi divided by pi, so square root of B.
Yeah, the easiest way is to cancel these pi's out before we go any further. I should have done that. I should have done that in the first one also, just to make it more straightforward. So yeah, so the square root of B. Well, we know that that r is the same as that r, right? So now we're going to set A over 2 equal to the square root of B. And we know that A is equal to B, so I can substitute A for B right there.
Oh, okay.
And now if I square both sides, I get a squared over 4 equals a. So now I have, without getting too complicated here, at this point you might want to start thinking, well, what might a be? Can you figure out what a is just looking at that? We can do it mathematically, but it's probably faster to just kind of experiment with a few numbers. What is
I was
a?
thinking 2.
Well, does that work?
Uh,
Because that's what I first tried also. And it doesn't work. In other words, 4 over 4 is not equal to 2. So what else might a be?
4?
Yeah. 4 works perfect. 4 squared over 4 is equal to 4. So a equals b equals 4. Now once we know what a and b are, it's easy enough to solve for r. Since a is 4, we have 4 pi equals 2 pi r. R must be 2.
Okay.
Now that was an awfully long problem. Let me just check their answer. Okay, I did kind of go the long route on that. Let's go back and take a look at that. Since I'm not sure what they did here. How did they get to this step? They got 2 pi r equals pi r squared. In other words, they said that since c is equal to, okay, I got it now. I did take the long about route on this. I apologize. If
That's fine.
if c is equal to a pi, and that's also equal to b pi because a is equal to b, and that's also equal to the area, then we know that the circumference is equal to the area. And if the circumference, in other words, we can get there a lot more direct than I did. Here, let me finish that up because it's, so the circumference is 2 pi r and the area is pi r squared. So we can immediately go to there, and then solving for r is rather easy. R is equal to 2.
Oh, okay.
Okay, so that definitely was a lot quicker. That first line is the key line on that problem. Kind of felt like as I was doing it, it was taking too long for one of their typical problems. This next page I've got photographed twice, and this is the clearest copy, so let's see if we can figure it out. Most of these questions seem to be short, so let's use this page here. Question 8 and 9 refer to this figure. What is the length of arc RS? Can you see that, or do I need to blow that up a little bit?
Actually, I do need it blown up just a little. I can't see what's inside the circle.
Okay. Let me do that here. Whoa, that's pretty good, huh?
Well, that's a lot better.
Yeah. Oops. As long as I don't cover it up, huh? So the length from here to here. Whenever they talk to you about arc length, think circumference. Because this arc length is a certain percentage of the circumference of this circle.
Okay, so it'd be 144 divided by 360 times 2 pi r?
Times 20 pi.
Okay.
Okay. What is that? Let's see. I guess you can plug that into a calculator. It looks like about 8 pi.
Let's see, we have 0.4, let's see, times 20, so 8 pi.
Yeah. Okay. That's one you could almost guesstimate based on the spread between their answers. In other words, they don't give you very close answers here. We certainly know it's not 20 pi or 40 pi, right?
Right.
Because it's a little bit less than half of the circumference. So a good guess was 8 pi, but then I saw that they've got two other answers here that don't have a pi. And 20 is relatively close to the same number as 8 pi. So although the fact that these are integer numbers and we know that pi has to be in the answer, we actually could pick 8 pi here without doing this math.
Wow, okay.
Okay? Because we know it's slightly less than half, and we know it has to be in terms of either pi or it's going to be a decimal. In other words, even if they put the equivalent of that, it's going to be a decimal number. It's not going to be a...
Right.
Okay, and what is the area of that shaded sector?
Okay, so the area would be 144 divided by 360 times pi 10 squared, so 100, 400? No. See, I can't do these in my head like you can.
Well, that's okay. You got that. You did that. That's the area, 100 pi.
And then times 0.4.
Okay.
Okay, so 40 pi.
Okay. All right. Now, I apologize for the... Oh, no, good. We can see this one. I was going to have to not be able to do this question because I could not read it on the other page. I couldn't read that angle. But good.
Okay, so I know that the other two angles are going to equal 108.
Okay. What kind of triangle is that?
I'm not sure.
Isosceles, because all radii are equal. So the key part of this problem is recognizing that this radius right here has to equal this radius right there.
Okay.
So that's an isosceles triangle, and the opposite angles have to be equal also. If the sides are equal, their opposite angles are equal. So this angle over here is also x. So half of this, 54 degrees.
Okay.
Since they both have to be equal. Okay.
Okay, so in this one, I think what I would do is, I'm not sure.
Okay? If you're not sure what to do, what's a good starting point?
Well, I know that they're trying to find A in terms of C, but...
Okay, so let's start with everything we know about A.
Okay, which is pi r squared.
And everything we know about C.
2 pi r.
Okay. Now, quite frankly, it was this problem that I had just finished looking at when I was doing the other problem that I took so long to do. Because the solution to this problem is what I did in the other one. Okay. How can we relate A to C? Because that's what they're asking for. They want us to relate A in terms of C. Well, we've got A in terms of R, and we have C in terms of R.
I am really not sure.
Okay, let's take the circumference formula and solve for R.
Okay, it'd be C divided by 2 pi.
Okay, and now let's take that R and plug it back into the area. In other words, area is now, instead of pi r squared, well, R is C over 2 pi squared. Now notice that we have A in terms of C. So what's going on here is we have three variables. We have area, circumference, and radius. And they each relate to radius, so if you try to get area relating to circumference, you have to do basically a substitution. Solve this for R and then substitute it into that.
Okay.
Okay. Now, we still need to simplify this because that's not one of their answers. So that would be pi c squared over 4 pi squared. Now we can get rid of that and get rid of that. So that should be the answer, which is number B. Oh, no, excuse me. That is number A. We got to be a little careful here. They definitely put similar looking answers down on this. Okay. All right. Now, unfortunately, we have to go to the next page, which is the one that is not real clear. In fact, it's terrible, but that's okay. I think I can make out these and write them down. Hold on. Yeah, that's not too bad. We'll be able to deal with this. Okay. So what is the area of a circle whose radius is the diagonal of a square whose area is 4?
That one would be 4 pi.
Okay. So let's see. The side of the square is 2. And they want the area of the circle whose radius is the diagonal of that. So there it's inscribed in a circle. So that's the way you did that?
Yes.
Okay. And this is what? Square root of 8, which is 2 root 2. Half of that's root 2. Pi r squared. 2 pi, is that what you said?
No, I had it wrong. I said 4 pi.
Okay. Did I do it right? Let's see.
Yes, you did.
Okay, so the
You did it right, I didn't.
radius of the square is half of the diagonal. So the area of the circle is pi r squared. Square root of 2 squared is 2, not 4. Yeah. Okay. The perimeter of the pentagon, the circumference of the circle.
Wouldn't they be even? 360?
Well, no.
No.
Remember, the perimeter is the lengths of the lines.
Okay.
So we're not dealing with angles. Conceptually, let's look at this little piece over here. What's longer, the side of this pentagon or the circle right there, that arc?
The circle.
And in this section up here, what's longer, the side of the pentagon or the arc?
The arc.
So which is bigger, the circumference of the circle or the perimeter of the pentagon?
The circumference of the circle.
Okay. Okay, let's see. The circumference is 2 pi r. The area is pi r squared. What's bigger, C over A or A over C?
I'm not sure.
Okay, well, what is C over A based on these two formulas?
Could it be 2 over, pretty much 2 over r?
Exactly. And what is A over C?
R over 2.
Okay. So which is bigger, 2 over R or R over 2?
Doesn't it depend on what the radius is?
Exactly. So we can't tell.
Okay.
Okay. Once again, the key here is to write these out. If you write those out on almost every question about circles, it will be helpful.
Okay.
All of these tend to require you to relate C and A, which is really working with radius. Okay. This one should be pretty easy.
Okay. Okay, the first one would be 4 pi, the second one would be 9 divided by 2 pi. So, oh, yeah, that's right. So that would be larger.
Okay, good. C is the circumference of a circle of radius r. What's bigger, C over r or 6?
Once again, wouldn't it depend what numbers we have for the radius? And
A little tricky. That was my first thought also, but not really.
okay.
Let's start out by this. What is C over R equal to?
2 pi,
Okay?
which is larger than 6.
Yeah.
Okay.
You got to be a little careful here. That was definitely my first thought here was we're not going to be able to tell because we don't know what C and R are. But then I realized that that's a fixed relationship, C and R. Always. Okay, let's see. I need to go down here. I can close this one out. Oh, man. My mouse, every now and then, it acts like somebody has hacked into my system, and I can't get to my mouse. Oh, good. We can read these. 17.
I'm going to say, well, let me see the sector again. That's times this. Okay, so it'd be 1/9 and then times the circumference, which would be 8 pi.
Not the circumference. Remember, we're dealing with area.
Oh, area. Okay, so it'd be 16 pi.
Okay.
So 16 over 9 pi for the first one. And then let's see, 8. 64 pi over 18 for the second one. Okay, so the second one, the area of sector B would be larger.
Correct. Now, you can certainly get there by doing the math, and that's what you did.
Yeah.
But when I look at this, I see that, well, that's half of that, right?
Uh-huh.
And it's 20 degrees instead of 40 degrees. But since area is pi r squared, when we square 4 and we square 8, the result is going to be, this is going to be much greater than half or double that. 64 is not double 16. It's much bigger. So 20% of a number that's more than double that has got to be bigger than 40% of this number squared. Now, it's not necessary to really view this as that, but if the question said circumference instead of area, circumference doesn't depend on squaring the radius.
Right, okay.
Circumference is straight linear, so the circumferences would be equal. Since this is half of a number that's double, this radius here, and circumference is just a function of radius, then this circumference, this arc length here would have to be the same as this arc length here. But because to get area we square the radius, then 20, I don't even care what 20 over 360 is all I know is that ratio, 20 over 360, is going to be half of the ratio of 40 over 360. So if my radius is more than double, and this is half, then this one has to be bigger.
Okay.
But like I said, it's not necessary to use that. It's just, if you can do the math, that's just as good on that.
Actually, I like being able to do it the way you show me. That way I get it done quicker.
Yeah, it's a little bit of a shortcut if you recognize that. It's kind of like saying this. It's very similar to saying, if I have a circle of radius 2, and I have another circle of radius 4, how much bigger is this circle than this circle, area-wise?
4 times bigger.
Exactly. It's not twice. It's 4 times bigger because you have to square the radiuses. Same thing with a square. If I have a square with side length 2 and another square with side length 6, the area of this is not 3 times the area of that. It's 9 times. So the virtue of having to square a key dimension means the area blows up a lot faster than just the linear relationship between the radiuses. All right, how about this one here? 18.
Well, I know that the area of half of the circle will be easy to come up with. I'm not sure about the triangle in the middle. Or the sector.
The sector in the middle. Okay. Well, there's one key piece of information about equilateral triangles. What is it?
All sides are equal.
What else? What about the angles?
They're all 60 degrees.
Okay, so what does that make this angle right there?
That would also be 60 degrees?
Right, because if that's 60 and that's 60, then that has to be 60.
Okay.
That is 1/6 of the area of the circle.
Okay.
So that's 1/6, that's half, or 3/6. So the shaded region is 2/3 of the area of the circle. And the area was 9 pi, correct?
Yes.
So we have 2/3 of 9 pi, so 6 pi is the area of the shaded region.
So they're equal.
Yes. But the key there was knowing the 60-degree angles. More so, well, you had to know that these were, it's 3, 3, and 3 also, because to get the area of the circle, you have to know the radius is 3.
Right.
Okay, these problems are always fun. Intuitively, do you have a feel by looking at them?
Intuitively, I would say that the shaded region of A is larger than B.
Okay. Now I don't get that same intuitive feeling.
You don't?
Well, not really. I don't know the answer, but I can't really compare the two because I have 1, 2, 3 there, and up here I got 1, 2, 3, 4. 4 by 4, and this is only 3 areas by 3 areas. So I don't, if I had to guess, I'm not sure what I would guess. In other words, that's how little of an intuitive feeling I have for this by looking at it. So we probably need to do the math. Math isn't as hard as it might appear. So all we have to do is figure out the areas of these circles, right?
Yes.
Subtract them from 144, which is the area of each square, and we'll have the area of the shaded region. So what's the area of each of these circles here?
Pi 9, or 9 pi.
Okay, so all 4 of them is 36 pi. So the area of the shaded region is 144 minus 36 pi for figure 1. For figure 2, sorry, I don't know why this is a right to left day, but so figure 2 is 144 minus, what's the area of each of these circles?
4 pi. Correct?
Yeah. And there's how many of them?
3.
9 circles?
Oh, yeah. Oh, I'm sorry. I'm counting up.
They're the same.
Well, I definitely know not to rely on intuition.
Well, I'm not sure that that would have been a good method anyway. I guess that it would have been because the areas of these two squares appear to be about the same. And I didn't really mean intuition. I guess I should have said visually. Can you look at it and make a guess as to which one would be bigger? Yeah, I'm not sure they're going to ever give you problems where you can solve them that way, now that I think about it.
Yeah, probably not.
No, not at this level. They're going to force you to do the math. It would be too easy if they gave you a problem. You could just look at it and solve it. So that was probably a worthless exercise anyway, trying to figure it out. Square and a circle have equal areas. Perimeter of the square, the circumference of the circle.
Well, on this one, I think I would pick a number.
Okay.
So maybe 2 for the square, so that would be
How about picking
4.
up? Yeah, 4 is a little better number. So that
Yeah.
you don't have to do with irrational numbers unnecessarily. So if our area is 4, then the radius of the circle is what?
2.
And the side of the square is what?
2.
So the perimeter of the square is what?
8.
And the circumference of the circle is?
Is 4 pi.
Circumference of the circle is bigger.
Okay.
All right. That does it with circles. We did move a little faster through circles than most of these sections. Let's go to solid geometry. This is probably an area where most people get the least amount of education in high school, is solid geometry, I would say. Number 1, can you read that okay?
Yes, I can. Okay. Volume would be 6 cubed. No?
The sum of the lengths of all the edges.
So much.
Let's see if we can draw a cube here, because we need
have-
to know how many edges there are.
Okay, and there are 12 edges.
You
No?
sure? Well, I don't know. I haven't counted them yet. Now let's see. We've got these 4, and then the back 4. That's 8, and then this one here This one here, that one here, that one there. So I think 12 is correct. So there's a total of 12 edges on a cube. So if the sum of their lengths is 6, what's each edge?
1/2.
What's the volume?
1/8.
Good. What's the volume of a cube whose surface area is 150?
Okay, and surface area would be 6 edge squared. So 150 equals 60 squared. Okay, so each edge is going to be 5.
Okay. So
And
what's
then
the
with
volume? Mm-hmm.
So the volume is 125.
Okay, good. It's a funny question.
Sorry, I started looking at the wrong problem.
Just as a quick aside here, if I take this curve right here, there's something called Gabriel's horn, which is an interesting theoretical mathematical problem, where you can create a Gabriel's horn here, if you rotate this about the x-axis, that has a finite volume but an infinite surface area. True story.
Huh.
It's a theoretical problem in calculus where you could actually create a horn. Well, you couldn't really create it because you have to take it out to infinity. But it creates a finite volume and an infinite surface area. And this problem started getting me thinking about it because our surface area was greater than our volume. Our volume was 125. The surface area was 150. But as we go up, the volume is going to get bigger than the surface area. But yeah, this is a fascinating problem as to how mathematically you can actually create an object that has a finite volume and an infinite surface area. But it's true. There's all kinds of problems like that that come up with that. So what's the surface area of a cube whose volume is 64?
Okay, so each edge would be 4.
Okay.
So 4 384.
If each edge is 4,
Wait, did I just do that wrong?
well, how did we, you had the surface area. What's the surface area equal to?
The surface area is equal to 6e squared for the edge.
So what's the result of 6 times 4 squared?
Yeah, it's actually only going to be 96.
Okay.
I'm not sure what I hit on the calculator.
Okay. What is the number of cubic inches in 1 cubic foot?
144.
Cubic. Keyword is cubic. What you got was the square inches in 1 square foot.
At least I know it's going to be bigger than 144.
By how much more?
I don't know.
Well, if this is 1 cubic foot, it's 12 by 12 by 12 inches. So how many cubic inches is in that cubic foot?
1728.
Right, 12 by 12 by 12. In other words, when you go from linear to area, you do square it. But when you go from linear to cubic, you cube it.
Okay.
this up just a margin. Fortunately, it doesn't give me that good a control on that thing. Huh. I can't do it with my mouse. I mean, I can't do it with this cursor. Hold on. There we go. Hopefully you can read that.
Okay, so this one I would figure out the volume of the rectangle, which would be 3 times 4 times 5.
Okay.
So 60, and then minus the volume of the cube, which would be 3 times 3 times 3, 27. So 33.
Good. That was easily the best way to do it. Here I was sitting here thinking out how I was going to do it more complicated by trying to draw a rectangular fish tank and then putting a cube in it and figuring out what the dimensions of the rest of it were. But I like the way you did it much better.
Well, it's funny because I actually did that one the way that, the reason I did it that way is because of some of the stuff that you taught me.
Right, with shaded areas. That's essentially
Exactly.
a shaded volume question.
Right.
And I don't know why I didn't think of doing it that way. Okay.
Oh, I do not like these ones.
All right. Well, here's our pipe. Normally we draw these vertically, but it's okay. It's 5 foot long. Has an inner diameter of 6. And ooh, this is not quite what I thought it was. Inside diameter of 6. So there's another edge to this pipe, and then that's the inside diameter. The outside diameter from here to here is 8. So it's a pipe that kind of has a thickness to the wall.
Okay.
Good grief.
Yeah.
Okay. There is a key thing here we have to consider, only I'm going to draw it normal. When you talk surface area of a right cylinder, what is the surface area equal to?
I'm trying to pull this out of memory. It would be 2 pi r squared. You have the area.
That's the area of
plus,
top and bottom, right?
and then plus 2 pi r. This, oh, the height.
The key here is recognizing what the surface area, the lateral surface area is.
Okay.
If this was a soup can, and I had a label on it, and I unpeeled the label, it would be a rectangle with height 5. Let's call this height 5 for our purposes.
Okay.
Do you see that? That if
Yes.
I unpeel it, it's going to be a rectangle. What is the width of this rectangle?
That's going to be the circumference.
Exactly, which is 2 pi r. So
Okay.
the surface area of the entire soup can is 2 pi r squared plus height times 2 pi r.
Okay.
So there's the formula for that. And the hardest thing to remember is that lateral surface area equals a rectangle when you unpeel it. So now let's go talk about this problem. Let's see if I can figure it out. If the total surface area inside and out, including the ends, well, let's figure out the surface area of the inside and the out. What's the surface area of the inside? Including the ends.
I'm really not sure.
Well, let's plug it in. We know R is 3 on the inside. So the surface area for the inside is 2 pi times 3 squared plus the height, which is 5 foot, times 2 pi 3. So that's the surface area of the inside. Let's do the surface area of the outside. Well, that's going to be 2 pi times 4 squared, because the radius of the outside of the pipe is 4, plus 5 times 2 pi times 4. If the total surface area is k pi, what is k? Well, how many total pi do we have here?
Let's see.
18 pi
48.
there, 30 pi over here. We've got 32 pi here, and we've got 40 pi over here. So we have 120 pi. So our total surface area. Okay, since that's not going to give us an answer, there's no k equals 120 there. What did we do wrong? Wondering if wow. Okay, the surface area that I calculated for the inside was basically a right cylinder of radius 3. But that's not what a pipe is. It's not closed on the end. So in other words, we don't have this part of it right there in either case. We've got something, but it's not the full area of the base. We definitely have the 30 pi and we have the 40 pi. That's the inside and the outside lateral surface area. So the total surface area is greater than 70 pi. Now, here's the problem. Let's look at an end shot of this pipe. We need to add this surface area right here. There's two ends. Okay? Looking at the answer, do we need to do the math? Looking at the answers.
No.
What's the answer?
84?
Correct. Wouldn't be that hard to do this math, because the shaded area is merely the area of the outside circle minus the area of the inside circle. But the fact is, we don't need to do that math because they didn't put any answers.
Okay.
They only put one answer where K was greater than 70. You understand that problem? I kind of fouled it up, but...
No, I do understand it.
Okay, okay.
And I do go over the recording, so I'll go over it again when I listen to that.
Okay. The first time I did it, I kind of made the assumption that the ends were solid, like that,
Uh-huh.
which doesn't really make sense given the description that they gave. you have a pipe that has an outside radius and an inside radius, it's not going to be solid on the end. In other words, this will be a hole. Looking at the pipe from the end, it'll be a hole right there.
Okay.
So we can't count the bases of these two right cylinders in our surface area. They're not fully there. The only base that really has any surface area is that right there.
Okay.
And we could figure that out, but we don't need to.
Yeah, I actually do think I understand that one.
Okay, good. The biggest problem with a lot of these is not the math, it's trying to figure out what kind of object they're talking about with the solid geometry. That's what
I know, yeah.
tough. They don't even give us pictures here. They're giving us descriptions of things, which really makes it hard. Okay. The height of a cylinder is equal to the edge of a cube. If they have the same volume, what's the radius of the cylinder? Well, this should be fairly easy. So the height of the cylinder is equal to the edge of the cube.
Okay, so if they have the same,
What's the volume of the cube in terms of h?
it'd be h cubed.
Okay, and that is equal to the volume of the cylinder. What's the formula for the volume of the cylinder?
It's h pi r squared.
So I can let h cubed equal h pi r squared. Since they want the radius, beautiful. If we look at our answers, they want an answer that is a function of h and pi. Well, if we solve this, that's what we're going to get. We can cancel this h out with one of those exponents. So r squared is equal to what?
It's equal to h squared divided by pi.
So r is what?
R is, let's see, I've got to write it out. The square root would be h divided by the square root of pi.
Which is answer A.
Okay.
Well, there's a lot of these three variable problems where this is a key step right there. And then setting this equal to this. And then solving for r. So, okay, let's go to the next one. Actually, I'm sorry, I ran over. I completely lost track of time. But why don't we end it there? That's a good ending spot. It's the end of my page.
Sounds good.
Okay? All right.
Okay,
And
David.
yeah, let's see. Your next session you've got is not for a while, huh?
Yeah, I'm going to be out of town.
Oh, okay. So August 8th.
Yes.
Sounds good. I will talk to you on the morning of August 8th.
Okay, thank you.
All right, Angela. Bye-bye.
Okay, bye-bye.